What is valve authority? Engineers who size control valves use the term valve authority to avoid selecting a valve that's too large for the application. A common rule of thumb is that the control valve needs to consume at least 25% of the available system pressure drop in its most open position to avoid control valve hunting. Valve authority is the ratio of the valve dP in its most open position to the total available pressure drop in the system. This problem is commonly faced in hydronics or the control of thermal water circulating loops. In these systems, significant energy is lost by sizing valves to always consume 25% of the pump's energy. Valve authority is also an issue when sizing valves for applications such as dosing or blending. This 25% lower bound limits the flexibility in valve selection and further limits the ability of process designers to achieve wide flow rate turndown ratios. Equilibar engineers have discovered that the 1,000 to 1 turndown of their novel control valve sidesteps the valve authority limitation and provides stable control of ratios down to 1 or 2%. This capability supports lowered energy consumption in hydronics loops and wide flow rate turndown ratios in dosing and blending, up to the limitation of the flow meter. Theory is great and all, but let's take a look at the Equilibar control valve controlling through a wide operating window with valve authority down below 5%. In our setup, a centrifugal water pump capable of about 10 psi output, typical of hydronic systems, pumps water from a supply tank through the system. As the flow increases, the output pressure decays as predicted by a classic pump curve. We have installed a Bronchorus Coriolis mass flow meter to provide precise documentation of our valve authority. We have a heat exchanger coil as our resistive load. dP increases exponentially with flow across the coil. The coil is an analog for any fluid resistance, such as a filter membrane, an orifice, or a long run of pipe. We have pressure sensors after the pump and before the control valve so that we can calculate the valve authority accurately using delta P. We are using an Equilibar half-inch GSD4 control valve to control the flow. Our ability to control at low valve authority allows us to install a larger valve here to get more thermal capacity out of the pump while also not losing control. We circulate the water back to the supply tank. Let's turn the system on and see what happens. Now we're operating the circuit at medium capacity. The flow rate is 1.05 liters per minute or 2/3 max flow. The pump is producing 10 psi and the coil system load has 4 psi resistance. The differential pressure on the control valve is 6 psi, so the valve authority is 6 divided by 10 or 60%. Let's explore the low flow capability. The flow rate is 0.07 liters per minute or 1% of max flow. The pump is producing 10 psi. The coil resistance has dropped to 0.2 psi. The differential across the control valve has risen to 9.8 psi. The valve authority is therefore 9.8 divided by 10 or 98%. Let's go back to our mid-range flow rate and then jump right up into the high flow rate. This is where the Equilibar low valve authority is demonstrated. This is the region that would not be possible with the limitations of traditional valves. We have increased the flow rate to 1.55 liters per minute, or about 99% of max flow. The pump output reduced slightly to 9.8 psi. The coil resistance has increased to 9.6 psi. Therefore, the pressure drop on the control valve is 0.2 psi, and the valve authority is 0.2 divided by 9.8, or 2%. Now let's demonstrate that we can actually control in this range. Let's lower the flow set point from 1.55 to 1.5. This increases authority from 2% to 10%. And lower the flow further to 1.45, increasing the valve authority further to 15%. And finally, lowering the flow to 1.4, increasing the valve authority to 20%. Contact an Equilibar engineer today to discuss how our control valves can improve your flow control application. Visit equilibar.com or click the link in the description below.